Hello everyone, I'm Frank and welcome to Frank Puzzles. And this is today's easy level puzzle. And it's called, Renban Tessellation by Michael Lefkowitz. And here are the rules. We have tessellation, where we need to fill each cell in the grid from the digits 1 through 9, such that there are no repeats in any row or column. Also, cells sharing an edge can't have the same digit. So, for example, all of these digits cannot be 6 because they share an edge with a 6. Same with these 4 cells here. Because they share an edge with a 6, they cannot be 6. In addition, each horizontal row and vertical column contains a non-repeating consecutive set of digits like 2, 3, 4, 5, 6 in any order. So for example, if this could be 2, 3, 4, 5, 6 in any order. It cannot be something like 1, 3, 4, 5, 6 because that does not form a consecutive set of digits. Imagine each row and column has to be essentially a Renban, in addition to the Renbans we have in the puzzle. So that's interesting. And then finally, we also have Renban lines, where digits on a pink line are a non-repeating consecutive set of digits in any order. So imagine essentially every column and row is a Renban, and that matches essentially so like if you imagine this is essentially what the puzzle is. That's what a tessellation is, right? And then these are, but I guess, yeah, it's a lot of lines there that to be drawn. So you have a similar rule set for each tessellation row and column as the Renban lines. But the Renban lines do not have to go necessarily in a row or a column. And in fact, they don't. Anyways, those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. So this must be the digits 1 through 3, 4 through 6, and 7 through 9. These digits must be either 3 digits adding up to 6. So that would be, or having a 6 in them. That would be 4, 5, 6, 5, 6, 7, or 6, 7, 8. So this must be 4, 5, 7, or 8 as a possible combination. So these 3 digits have to be either, again, so this row 5 has to have sets of 1, 2, 3, 4, 5, 6, and 7, 8, 9 on the Renbans. Because there's no other breakdown that would work, right? If you tried to have 6, 7, 8, 9 is left out from a Renban, which it has to be on a Renban here. Same with if you have 3, 4, 5, 1 and 2 are left out from a Renban. So therefore, this has to be 4, 5, 6, 7, 8, 9. But if this is 4, 5, 6, they would all be sharing a border with this cell. So this cannot be 4, 5, 6. So this must be 7 or 8. So this has to be a 7, 8, 9 triplet. Therefore, this is 1 through 6 in the rest of the row. 6 cannot be here because it's sharing an edge with this cell. This is 7, 8, 9, and they all share an edge with this, so this can't be 7 or 8. Therefore, this is 4, 5. So for this to be a Renban, essentially, or a set of non-repeating consecutive digits, it has to be 5, 6, and 7. So this is 5, this is 7, and this must be 8 or 9. That means this set of 5 digits has to either be from 8 down, which is 8, 7, 6, 5, 4, or from 9 down, 9, 8, 7, 6, 5. 5 cannot be any of these, so 5 has to be one of those two. So we are guaranteed a 5, a 6, a 7, and an 8 in this column. 6 can't be any of these cells, so one of these must be 6. This can't be 6 because of a 6 in the row, so this has to be 6 here. We are guaranteed a 7 in one of these cells, so one of these is 7. That's not as helpful, though. Let's put down what they can be. 4, 5, 7, 8, 9. And this can't be 5. So this is 4, 7, 8, 9 as possibilities. This is 6, and these 4 must form a Renban. Well, without a 6, 7, 8, 9 cannot be on that Renban. So this has to be 2, 3, 4, 5. So this is 2, 3, 4, 5. This is on a Renban from 1 through 5. So that means the Renban has to be 1 through 7 at most. But this can't be 6 either way. This can't be 6 either way because of the 6 in the row and the 6 in the row. So you can't have 5, 6, and 7 here. So this can't be 7. This is 1 through 5. This is 1 through 5. These can't be 5 because of the 5 in the row. So we're guaranteed a 3 here and a 3 here. It could just be that cell, which is fine. If this were 3, this would have to be a 1, 2, 1, 2 pair to make that Renban work. I guess that's possible. Hmm. Hmm. So we're guaranteed a 3 either here or here. Hmm. Can this be 1, 2, 3? And I think the answer to that is no. If this is 1, 2, 3 as a Renban, that means this is 1, 2, 3 as a Renban. But 1... Never mind. That works. What does that mean? Hmm. This is interesting. That means we have 3 digits here, which are consecutive, and they don't repeat. I guess it doesn't have to be here, right? This digit, well, it can't be. This digit cannot be any of these 3 cells. It could be any of these 6, though. That isn't okay. That doesn't tell us very much. Never mind. Hmm. These digits have to be from, can be 1, 2, 3 up to 7, 8. It cannot be 9 because 9 will require 7 and 8 to be with it. So this cannot be 9, but it could be 1, 2, 3, 4, 5, 7, or 8. This can be 1, 2, 3, 4, 7, or 8. Hmm. Hmm. Mm hmm. That's interesting. If this is 1, that guarantees this to be a 2-3 pair, to be on a Renban with it. That would also guarantee this to be a 1-2-3. So this would be 1-2. So if this is 1, these are all. Oh, that doesn't work. If this is 1, that means this has to be 2 and 3 here. This must be 2 and 3 here, and this must be 2 and 3 here. But then we have 3 sets of cells which require specifically the digits 2 and 3, which is not possible. So this cannot be 1. If this is 2, that could work, though. This would be 1-3, but you could have 3-4 be some of these, right? So that does work. So 1 cannot be here. Um, Interesting. Hmm. Okay. If this is 5, this would have to be 4 and 6 guaranteed. This would have to be 3-4, 3-4. Ah, and that's not possible. So again, if this is 5, this is 4, 6 as a pair. So we have one set of 4s here. This would have to be 3 and 4 and 3 and 4. But then we have 3 pairs of 4 in those 2 columns, which is not allowed. So this cannot be 5 either. If this is 2, it could work with one, it would have to be 1-3 here. It would be, it could be 1-3 in one of these sets, and then 2, and then, oh, you'd have 3 sets of 3. You have to have 3. So if this is 2 or 4, you need 3s in these Renbans. But if this is 2 specifically, this requires 3 sets of 3s here in the 2 rows, which is not allowed. So this cannot be 2. So this is 3 or 4, which means the rest of the Renban cannot be 3 or 4 because the 3 or 4 specifically has to be here. If you have 3, that would guarantee 1 and 2 here. You could have 5 and 4, and then the other ones being 1 and 2. That is possible. Hmm. If you have 4 here, this is 5 and 6. You would have to have 3 here and 3 here. So 3 could not be one of these 2, which means 3 is one of those 2. Which is possible. This is problematic if it's 3. If this is 3, this becomes 4, right? 3 cannot be either of these. This becomes 4, 5, and 6. But then 3 cannot be here. 4 cannot be here. 1 cannot be with 4. And that's a contradiction. So this cannot be 3 here. Though it could be 4. That seems to work okay. Hmm. Hmm. Can this ever be 1? I think the answer to that is no. If this is 1, that means this is a 2-3 pair, but 1 can only be on a Renban with 2 and 3, and they would both see that. So this can't be 1 here. Similarly, if this is 2, this would have to be a 1-3 pair, and then the problem is the 2 would have to have a 3 guaranteed here, but these 3s would both share an edge with these. So that would not be possible, so this cannot be 2. So if this is 1, 2, and 3, this would have to be the 3, so this can't be 3 here. If this is 3, this would be 1, 2, 1, 2, and this would have to be 4 and 5. That's possible. 6 could be here if this is 4 and 5, and this would be 7, 8 as a pair. Otherwise, this doesn't form well as a Renban. Because, so we have 3 here. That forces this to be 1 and 2, which means this is 4 and 5 specifically. So let's see what they can be. So this would have to be 4, this would be 5. If this is 4, this is 5, 6, which means this would have to be 2 and 3. If this is 5, this would be 4 and 6, and that would not work. Because 5 has to have either 4 on a Renban or 6 on a Renban. And they would both be eliminated by both of these being 4 and 6. So this cannot be 5. If this is 6, this would be 4, 5, and this would be 7, 8. Interesting. Hmm. Hmm. Oh, that's interesting. This obviously cannot be a 3-4 pair. If this were a 3-4 pair, they would eliminate all possibilities for that cell. So we're guaranteed to have at least a 2 here, which means as a Renban, this can never be then 3, 4, 5, 6, 7, 8, 9. So 9 cannot appear on this Renban. So this could be 1 through 7. No 6. Sorry, 1 through 7 or 2 through 8. um, this could be 4 and 5 though here. So that could be 3 through 9 potentially. Um, hmm. Hmm. Okay. Hmm. Kind of stuck right now. Hmm. Okay. So say this was 6 and this is 4, 5. That would force this to be 3. This would be 7 and 8. That's interesting. So this would be 1, 2. We'd have 7, 8 here. Obviously, 3 could not be any of these. Hmm. Hmm. Okay, that's not helpful. Let's try the other way. What happens if this is 3? If this is 3, this becomes 4. This is 1, 2. This has to be 5, and then this is 4. So 4 cannot be any of these. 4 and 5 cannot be any of these. That's interesting. That would mean this is 2, 3, 4, and 2, 3, 4, right? Well, this couldn't be 4. This couldn't be 2 or 3. This couldn't be 2 or 3. This couldn't be 4. So this is a 4, 5 pair, which eliminates 4 and 5 in the rest of the row. So this can't be 5. This would be 2. This would be 3. This can't be 3 or 4 or 2. No 4. So one of these would be 7. The other one would be 1 or 8. Well, this cannot... This would have to be 2, 3, 4, 5, 6 at most. So this couldn't be 7 or 8. So that would force this to be 1, that to be 2, that to be 1. This would have to be a 4, 5 pair, but they would both be 5 here. So that's a contradiction that we'd arrive at. So this can never be 3 then in this square. So this is 4 or 6, which means it's with 4, 5, or 6 here. So this cannot be 4 or 5 because of the 4, 5, 6 triplet here. Therefore, this is a 3 here, which makes this 1 or 2. None of these can be 3. You can only have 1, 3, 4, 5. So the other one has to be at least 2, 3, 4 or 1, 2, 3. So we are guaranteed one of these is 3, 4, and 5. So one of these is 4. It cannot be, I guess it could be 2, 3, 4 twice. No, because then that would require 3 2s in columns 4 and 6s, which is not allowed. So one of them has to be a 5. It can't be 1, 2, 3 and 2, 3, 4 because we have the same problem. 3 2s are required for these 3 Renbans. So one of them is 3, 4, or 5. So this is guaranteed to be 5, which means this cannot be 5. Where's the 5 in column 7? It has to be here. So this is 5. 4 is guaranteed to be here, so this cannot be 4. And this can't be 4. The other one is either 2, 3, 4 or 1, 2, 3. Either way, there's a 2 guaranteed on one of these Renbans and the 2 guaranteed here. So that eliminates 2 from, we have 2 2s in columns 4 and 6. So this cannot be 2 and this cannot be 2. So one of these is a 2 guaranteed, which means this cannot be 2 because it's sharing an edge with both of them. Therefore, as a Renban, this is either, it could be 3, 4, 2, or 3, 4, 5, or 1, 3, 2. So 1 cannot be here. 4 cannot be here. Yeah, if it's 4, it could be 3, 2, or 3, 5. If it's 1, it's 3, 2. So this is 2 or 5. This can't be 5 because of the 5 in the neighboring cell. So this is 2. Which means 2 cannot be here. This is 1, which makes that 2. This can't be 1 or 2, so it's 4. This must be 3, 4, and 5. This can't be 4 because of the 4 in the column. And this can't be 4 because of the 4 touching it. This can't be 5 because of the 5 in the column. This 4 eliminates 4 here, so this must be a 1. Okay, this cannot be 1. To make a Renban, this must be 1 through 7, so this can't be 8. This is 7. So this can't be 7 here. This has to be a 2, 3 pair. So since this is 2 and 3, to form a Renban for this column, it must be 2, 3, 4, and 2, 3. Which means this can't be 4 here, this can't be 4 here. This 2, 3, this 2 eliminates 2 in the rest of the row, so this is 3, which makes this 2, which makes that 3. This can't be 2 or 3, so it has to be 4, 5. Where's the 2 in row 7? It must be here. So this is 2, or specifically on this Renban. These are the digits either 1 through 7 or 2 through 8. So this cannot be 9. These are the digits 1 through 7. So this neither of these can be 5. What is this then? We have 3, 5, 6, 7. 3, 5, 6, 7. These can't be 5 because of the 5 neighboring it. This can't be 6 because of the 6 neighboring it. This can be 3, 4, 5, 1, 2, up to 7. So this is 1, 2, 4, 5, 6, 7. This can't be 2, 5, or 6. This can't be 5. So this can never be 1. If this were 1, it requires a 2 on this column, and we don't have it available. So this can't be 1. It could be 2, 3, 4, 5, 6, 4, 5, 6. This can't be 5 because of the 5 neighboring it, so this is 6, which makes that 5. This 6 eliminates 6 in the rest of the column. This can no longer be 1 through 6. So it could be 2 through 6 or 3 through 7 here. We have to have a 5 somewhere here, though, so this must be 5, which means this can't be 5. That's 3, which means this can't be 3, so it's 4. So that eliminates 3 in the rest of this column. This becomes a 6, 7 pair, which eliminates 6 and 7 in the rest of the column. So this can't be 7. This is 5. This is 3, 4, 5, 6 with 2 or 7. So 4 is one of these two. This is 1, 4, 7, or 8. Five has to be with, well, 5 has to be with either 3, 4, 4, 6, or 6, 7. So it's 3, 4, 6, 7. This can't be 3. This can't be 4. This can't be 6, so therefore this can't ever be 7. Because if this were 7, that would force this to be 6, but it can't be 6 because of the 6 in the column. The remaining digits in column 4 are 3, 6, and 7. These digits have to be... These digits are consecutive with 3, 6, and 7. If it's 3, you cannot have 2 here, so this can't be 1 and 2. So if it's 3, it specifically has to be 4 and 5. This can't be 5 because of the 5 in the row, so that's 4 and that's 5. If it's 6, it could be 4, 5, 6 again, so this would be 4 and that's 5. It could be 5, 7. This would be 5 and this would be 7. If it's 6... Sorry, if it's 7, it would have to have a 6 here if it were going down, but it can't have a 6 there. So it would have to be 8 and 9. Well, this can't be... This could be... This specifically can never be... You can't have an 8 in one of these cells, so this would have to be an 8 if that were the case. And this couldn't be 8, that would be a 9. 3 can never be on a 3-length Renban with 6 or 7. So this cannot be 3. It's 6, 7, 6, 7, and this must be 5 or 8. Okay. I don't... this could be 2 still. 2, 3, 4, 6. Well, this can't be 4 anymore. Because... Oh, it could be 4, 5, 6. That actually does work. These are both... This is a 6, 7 pair. That eliminates 6 and 7 in the boxes that they both touch. So this can't be 7. So this is either 4, 5, and 6, or this is 7, 8, and 9. Interesting. So one of these two digits is guaranteed to be 7. So that means this can never be 7 here. Okay. Interesting. I think one of these digits is guaranteed to be an 8, right? If this is not 8, so this is 4, 5, 6, that would force us to be 8. Otherwise, this is 8, which means this cannot be 8. If this is 2, that would make this 3, 4, 5, 6. So if this is 2, we have 3, 4, 6, which makes that 7, which makes that 6, 5, 8. It seems okay. This would be 4. That would make this 8. This would have to be 7 to form a Renban, and that would eliminate all possibilities for that cell. So this cannot be 2. Okay. Since that can't be 2, this is 4, which makes this 7. This can't be 7. This can't be 4, so this must be 8, 7, and 9. 7 eliminates 7 here, so it's 6, which makes that 7. We have 4, 5, 7, 8. We need a 6, so that's 6, which makes that 3. This must be 3, 4, and 5 then. So this cannot be 4. This 8 eliminates 8 here, so it's 5. This can't be 4 or 8, so it's 1. Therefore, this must be 4 to add up to make that Renban. Therefore, this is 8, that's 9, and this must be a 7. And that's the solution. Interesting. Yeah. These tessellations are very interesting, actually. They have a lot of the same features as normal Sudoku variants, but they have the added Renban effect. I'm still not, like, familiar with what the implications are. I feel like there are certain ones, like, you have to have, obviously, 5 5s in these cells, right? Is it? Maybe not. Yeah, you're not guaranteed. You have to have a 5 here and a 5 here, but you're not guaranteed. Huh. I don't know. I'm still trying to figure out the implications about certain things about tessellation. But it's fun, actually. Is it enough of a variant to do, like, a different puzzle? I don't think so, because essentially it's the same as Sudoku. It's just you don't have the box constraint, right? And you have fewer limitations in the rows and the columns, but it's essentially still doing similar things. I don't know. I'm not sure if I should be doing this as a variant Sudoku or should have its own sort of puzzle type, right? Let me know what you guys think. Do you guys think that these should be continuing in the easy variant Sudoku puzzles, or if they should be another puzzle type in themselves? It feels very similar to Sudoku to me, but that's just maybe something that I feel personally. Anyways, I hope you enjoyed this solve today, and I'll see you next time on Frank Puzzles. Take care.